Good afternoon, everyone. Thanks for attending today's webinar session. It is focused on lessons learned from the Marshall Fire. I know that we previously had the topic of the residential IECC 2024 versus 2021, but seeing as though that has not been released yet, we changed this session and the session on the 26th to two different topics. So today is lessons learned on the Marshall Fire as it relates to code. And Robbie created the training materials today, and it is sponsored. This session series is sponsored by the Colorado Energy Office. So Robbie and I have been working with the Colorado Energy Office to provide trainings just like this one. I know a lot of you guys are frequent attendees of the webinar sessions, but we also have a bunch of other types of trainings. Particularly, I want to highlight the role-based trainings that are available. There are more in-depth sessions that we create, goes through the IECC and the requirements as it relates to your specific role when complying with the energy code. So whether you're an architect or an engineer, or you work for the building department, we have trainings for all of those, and we'll likely be setting up a road trip or something along those lines in the fall. So stay tuned, and we'll be highlighting those role-based trainings there. And one other change in our webinar series is that we also added a session on Q&A. So basically just bring any of your code questions. It's July 3rd, which I know is a tricky time, but if you have any code questions, or if you want to pop in and just hear what other people have to ask and learn from that, you're welcome to attend. And that registration link I'll put in the chat shortly. Most of you know about the Code Adoption Toolkit, but I do want to highlight the helpline in a minute. But first, let me talk about technical assistance for code adoption. We've got that funding available to help jurisdictions update to the 2021 or eventually the 2024 when it's released across the state. So reach out if you're interested in gaining that technical assistance. And then that code adoption toolkit I mentioned, there's also the Colorado Codes helpline, which we answer questions on any of the I codes. So if you have a question about how something applies, or how to inspect, or how to review for plan check, we're here to help, and you can submit a question and we'll get back to you in just a few days' time. And that's all of my portion, besides just the housekeeping parts, which is, at the end of the session today, we'll open it up for questions. You'll be able to put your questions in the chat, Q&A, or raise your hand. And with that, I'll pass it over to Robbie to talk a little bit about the Marshall Fire. Thank you.
Great. Thanks so much, Erica. I appreciate it. And welcome, everybody. Thanks so much for joining us today. I'm actually going to turn off my video again until the end here, so you can concentrate on the slides, but please don't hesitate to jump in if you have any questions. There will be a couple what I termed poll questions, but we're not going to actually run a poll. We don't really have time for that. So just put your comments in the chat so that everyone can see it, and we'll go from there. Okay, so lessons learned from the Marshall Fire from the IECC perspective. Just as a reminder to us, the Marshall Fire happened on December 30th, 2021. It was an interesting year that year because we had below normal precipitation at the beginning of the year. Then we had above normal precipitation, and then we had below normal again. The fire happened, and the day after the fire, it snowed. So it was a pretty crazy time for us. As you probably know, the Marshall Fire happened and destroyed a little over 1,000 houses, so 1,084 houses. It was the most costliest fire in Colorado history, largely because of where it was located, but also because, obviously the damage and whatnot that happened there. These troublesome fire in Grand County, in comparison, destroyed 366 homes and was a $543 million event, whereas the Marshall Fire was a $2 billion event there. And to put that into comparison to some of the fires that have happened in the past in California, where 11,000 properties were destroyed and 10 billion in property damages. But so these fires are definitely costly. They're happening in unforeseen areas where we wouldn't typically think of it as a wildfire, but it is happening there. The housing stock was primarily built in the 1990s, not super efficient, not very fire resilient. We saw vented attics, vented crawl space, dense neighborhoods, wooden fences and decks connected to houses and whatnot. So again, not really thinking about fire resiliency. One thing that we learned that I'm not sure that I put in here was that fire resiliency can make a huge difference. And that really was exemplified in the Lahaina fire. If you look in the Lahaina fire, you'll notice that one house survived the Lahaina fire not because they consciously did fire resiliency measures, but unconsciously, just because they were cleaning up the lot and had defensible space added to their lot before the fire happened. That house survived there. They got at least a 5-foot separation between the house and burnable structures there in any way. But anyway, you can look at that and take a look at that and see what you learned from that experience there. One of the things that we did learn about fire and not necessarily in relationship to code per se, but that when you make a claim with your insurance, that they're looking for is what's called the measure of the indemnity. You know, how much does it cost to rebuild? And that estimate of the cost of rebuilding happens with regards to rebuilding the house that was destroyed exactly as it was destroyed, rebuilding that anew and trying to cost that, you know, regardless of what you're actually going to do on that lot, what you're trying to get a payout from the insurance company on is based off of what was lost, what was actually lost there. Then on top of that, you're going to be rebuilding that exact same house that was lost, but build it back to the code that area is actually on. And so often the insurer is offering a much lower cost estimate of what that's going to take than the reality there. And so there's a group out of California that's been developing a way of actually being able to define the damages that occurred there and create an estimate that insurance companies will actually abide to. So that this is something that you might want to take a look at there. And if you're a builder or somebody in the construction industry that's used to taking estimates, this is a kind of burgeoning field with resiliency and severe weather event destruction on houses that's kind of coming into its own. And there's kind of a little niche, a business niche there to do this in an economical fashion where you can actually be helping people, but not gouging them like private assessors or the insurance company are trying to do that. But why ultimately I bring this up is that what we saw in the Marshall Fire area is that the Boulder codes and the Boulder County codes and the specific jurisdictions that were involved in the fire had just updated their codes. So Boulder County hadn't updated their codes, but their code that they call the Build Smart code for residential construction was basically deemed to be equivalent to the 2021 IECC. The city of Louisville had just adopted a zero energy appendix to their 2021 IECC adoption, and the town of Superior was just planning to adopt the 2021 codes there. And what we saw because of the fires and because one of the lessons learned that we learned basically from the fire was that you need to get control of the narrative of what's happening and how things will get rebuilt as soon as possible. We saw that these jurisdictions, especially Louisville and Superior, were forced to give people choice in how they were going to rebuild. So they gave, in the case of Louisville, they gave back the option of building to the 2018 IECC, the 2021 IECC, and or you could choose to adopt or build back to the most recent code adoption there. And ultimately where that happened was going back to the claims for insurance is that the Home Builders Association went out and basically created some hysteria, quite frankly, that the cost differential from the 2018 to the 2021 IECC was somewhere in the range of $100,000, and people, already feeling that they were underinsured, felt that they couldn't do that. But they didn't take into account that that part of insurance that says that they have to rebuild the house that was built to the codes that the jurisdiction are on. So in essence, some homeowners have lost out on some money that they could have gotten back to rebuild to a more the most modern code that the jurisdiction was on there. So that is definitely something that we learned. And this statement from the city council member basically points out that they believe that they should have stayed on the 2021 code in that adoption, but basically the narrative had gotten away from the code jurisdictions there, and they just had to provide this choice there. And like I said before, we need to talk about reality, not try to hype up things there just because home builders or others in our communities want to build to a lesser code and or feel that the cost of construction and really the first cost of construction is too high, that it's impacting their margins and whatnot like that. So there is this big lesson that I think we need to learn from this experience about trying to control the narrative and figure out what is actually best from a code perspective for the people that are having to actually rebuild their homes there. Luckily, we saw that Xcel Energy came into the equation here and offered some pretty outstanding rebates for these houses that were being rebuilt. So just if you were to rebuild to the 2021 IECC, you would get $7,500. And then if you did these more energy efficient programs there, that you would get even more money. And what we saw is that the Energy Star version 3.2 plus Next Gen, which is this new electrification program, has become quite popular there. And in addition to that, the Colorado Energy Office is offering rebates for rebuilding if you also electrify your house. And electrification from the state's perspective means installing a heat pump to heat and cool your house, installing a heat pump to heat water, and then electrifying your cooking. So those three things that make the most sense for getting electrification. And then from a greater perspective in the Marshall Fire, with regards to Xcel and the state, it doesn't mean that you can't bring gas to your lot there. It just meant that you couldn't use gas for heating, cooling, and water heating as well as cooking. But let's say you wanted a gas fireplace or a gas fire pit outside, you could bring gas in for those types of things there. So when we're talking about electrification and this move towards starting to pre-wire our houses there, we're also maybe needing to think about what type of things should we target versus what types of things might be amenities that people still like that could still be added to the house there. So anyway, looking at what's happened so far with the rebuild, we have 73% of the homes that have been permitted to rebuild. So they're either have rebuilt, are in the permit process, or are just starting rebuild. That leaves about 25% of the people that have either decided to move on and sell their lot, or to I just haven't figured out quite yet what to do there in that case there. What we see of those people that have permitted, about 39% have decided to rebuild to the 2021, which means that a lot of people took that option to rebuild to something else. Some have rebuilt to generally speaking, when you've rebuilt to the 2021 IECC, you're also going to do that would cover Energy Star, DOE, Zero Energy Ready, or Next Gen, or the Passive House there from a permitting perspective, even though they might be going beyond what the 2021 IECC. But again, that leaves a significant amount of people that rebuilt to the 2018 IECC there. This just is kind of talking about that in a different way here based on building permits. Here you can see that about 34% were at the 2021, and about 30% of the people that are permitted so far were built back to the 2018 IECC there. I highlight Passive House and Energy Star Next Gen because that gives us an indication of the folks that have decided to build back with electrification in mind there. Okay, so one of the lessons learned definitely is that these utility rebates are one way, or in a sense, a right way path forward to help incentivize people and get people thinking about what more they could do, how they might be able to rebuild better than they had in the past there. However, what we do see here is that rebates that only affect the consumer and not also the builder and potentially the architect or tradespeople mean that the builders are basically putting the responsibility on the homeowner to not only understand the rebates, but understand the rebates and how they affect the construction of the house. And we know that homeowners have limited knowledge about construction and electrification and building science and efficiency, fire resiliency, and all these issues regarding the reconstruction of their house. How can they be assured that when a program requires a specific Energy Star qualified cold climate heat pump to be installed in their house, how can we assure that the homeowner who's being responsible for that is going to be able to ensure that that happens, versus a builder or somebody that's in the trades taking on that responsibility to make sure it happens there. So what we also know is that these incentives are going to be pushed down into existing homes there as well. So when we're pulling permits to replace heating and cooling systems or water heating systems or whatnot, they're going to be incentivized to electrify those systems there. And we want to try to better ensure that the best choices are made so that they not only get the most efficient equipment installed, but that they actually can apply and receive these incentives and these rebates that are out there. From a new home construction, we have the 45L tax credit that is incentivizing builders to actually understand Energy Star, because they can get $2,500 as a tax credit as the builder of an Energy Star home, or if they're building a DOE Zero Energy Ready home, they could get $5,000 to that. And then Excel Energy is coming out with a new homes program to replace their new homes program. It is not out yet, but this is likely what it's going to look like. So there's some significant rebates and incentives that go back to the builder in this case. If they build to the Energy Star Next Gen program, which means that the core house is efficient, and then they're electrifying that house. And when there are incentives in the $10,000 to $15,000 range there, we're going to see a lot of builders take advantage of that. And so this is something that we learned from the Marshall Fires, that incentives work, but they need to be at a level that truly incentivize people to do things. So you should be assuming that sometime in the future, you're going to be getting houses that are not only complying to your program, but going way beyond that program. So we need to think about how we're going to assess those houses, how we're going to inspect those houses as we move forward there. Another lesson learned from the Marshall Fire is that custom builders were the majority of the builders that were rebuilding these houses. They have a limited understanding of the IECC. They have a limited understanding of building science. Their experience with energy raters has been limited as well. And their experience with energy modeling is limited. And ultimately, they're adverse to risk and change. The industry as a whole is adverse to risk and change, which means that it was difficult to get builders to actually take the responsibility that they needed to take in order to successfully rebuild a home to the requirements of the rebates that were out there, let alone to the requirements of the code that's out there as well. We see that builders have limited experience with building programs, especially custom builders, meaning that they haven't built to the Energy Star program or the DOE Zero Energy Ready Home program. Generally speaking, those programs are really trying to focus a lot of their attention on large national production builders because they basically have bigger impact on a national scale when they do that. They're not trying to say that they're not open and wanting custom builders to build there, but quite frankly, custom builders are building one house at a time, and it's harder for them to change their whole process to build to a program or a code, even to some extent. Custom builders are therefore not really understanding about the cost effectiveness of building to these programs. They're not understanding the incremental costs that are associated or not associated. For example, going from the 2018 to the 2021 IECC, there's limited to really no incremental cost depending on the compliance path that you're actually going to use. So when they're going into building with these programs and sometimes codes, they often go into it overconfident and not understanding what they don't know and how to move forward successfully. So ultimately, builders, especially I think the custom builders, need some help. And when we talk about what we learned here, we see that there are these different compliance paths that are available to the builders, and that ultimately, when we choose or builders choose to use the prescriptive path of code, which is often the question that they throw out there, is just tell me what to do. And so we point them to the prescriptive R value table. I think that we're often doing them a disservice there, because the biggest benefit from energy modeling, even if it's a very simplistic energy model like the ResCheck energy modeling tool that's used for the area weighted U value compliance approach, the benefit of that is that we can fail fast and succeed even faster, meaning that we can do different scenario modeling and say, yeah, I cannot install R60 in my attic, but I have to trade that off for something else. And so that scenario modeling really leverages this idea of trade-offs. And trade-offs are basically saying that we need to do something more in one location so that we can do something less in another location, while at the same time keeping a balanced energy budget that's defined by the energy code. And if we can keep that balanced energy budget, we can figure out the most cost-effective way to meet the intent of the codes and or programs that we're working with there. So when we push people or we don't challenge builders to use these more sophisticated energy compliance approaches for the IECC, I think we're doing them a disservice, because they don't understand why they're being asked to do something. They're not thinking about it from a cost savings or cost effectiveness perspective, and they just have the feeling from the energy codes that it's just burdensome and not cost effective. costly in other way of talking about it, and that we need to make sure that we help them understand what the code is trying to do, the building science that's wrapped into the code, and to ensure that we're going to have houses that actually perform there. So one of these poll questions that you can just type in a yes or no is Energy Star for new homes an above code uh, program, or is it equivalent to code? What are your thoughts real quick there? And you can take a second and type just yes or no into the chat there and get an idea of what we can get a quick idea of what you think. So we have one that says no, some that say above, some say yes. It's kind of all over the place here. So what I wanted the reason I asked that question is because I wanted to throw out that codes and programs all have requirements. They all have basically some type of adoption, and they have enforcement. From a code perspective, we see the requirements in the code from section R402 through R404. And those requirements in the 2021 IECC are all labeled as basically mandatory because they took out the word mandatory. Requirements are requirements, and basically they're mandatory. Um, in the same way, Energy Star has requirements that you have to uh, institute or execute in your home. From an adoption perspective, you can change those requirements when you're talking about codes, but it's a voluntary adoption for a builder to do the Energy Star program, and you can't change any of those requirements. And then from an enforcement perspective, we have combination inspectors. We have other inspectors that go into houses and inspect for code compliance there, but they don't look at everything that's required in the home or required of the builder. But the builder is still expected to execute those requirements there. From an Energy Star perspective, for example, those things are actually enforced, and they won't be able to proceed to get certification unless those things are actually executed in those requirements are actually executed in that house. So it's not that the difference in the codes and these programmatic building structure isn't actually the requirements, it's more the enforcement. And because they are focused on energy efficiency, for example, they're not tasked with looking at all the other things that are happening in that house there. So we're getting houses that perform and perform much better there. So we see, I'm sorry that um, my animation, I think, is off here, but we'll just go with it. We see that we have these requirements that are based on the code. So again, in the code, we have insulation. We have to now we have to certify the R value of the installation that's been installed in the new section R303.1.2 for the 2021 IECC. But we have the specific insulation requirements and the air barrier and air sealing requirements that are based in the code. And again, those requirements, along with air leakage and duct leakage and ventilation measurements, are also required by programs like the Energy Star program. From an inspection perspective there, we have the ability to do inspections through the jurisdictions or approved third parties, which would include air and duct leakage and ventilation testing there. And then in the section R405 and R406 compliance options there, you have third-party inspection that's happening regardless of what the jurisdiction is doing from an inspection perspective, because we have to turn in a proposed document to get our building permit. So we're basically telling the jurisdiction what the builder is proposing to do in that house, and then that has to be confirmed and confirmed not only through inspection through the jurisdiction, but has to be confirmed through a compliance document there. And because that compliance document has to be generated to get to your certificate of occupancy, it means that some level of inspection is happening out in the field there by generally an approved third-party inspection agency there. So what we see here is that the focus on inspection is really moving towards performance, asking ourselves the question, is it there and does it work? So from that perspective, we see that this fan is there in the house, but has it been installed so it actually works and functions? In this case, the duct is tied into a knot, and obviously it's not going to work there. So what we're learning from programmatic inspection is that we're not only looking for the item as it's been installed, but we need to ask that supplemental question. Does it work as it's actually been installed? Or are cavities being used as trash cans in this case here? Are these assemblies there? Are the air barrier details that are called out and are requirements in the home there? And have they been installed so they actually work again? Or has the air barrier been cut short and it's getting bypassed there? So that, again, the question, is it there and does it work as it's been installed, is an important fundamental thing that we've learned, way before the Marshall Fire, but I think the Marshall Fire has brought it to our attention once again that we need to be asking those questions. We need to be looking at these details. And if we don't have time to be looking at these details, we ultimately need to be thinking about how do we engage energy raters and energy consultants to fill in for us if we can't do that. We need to figure out what the infrastructure is in our communities and help build that infrastructure as we're doing through a state of Colorado Energy Office grant. We're starting to do additional trainings in rural areas of the state to be able to build the infrastructure for people who can do blower door testing and duct leakage testing, and potentially grow into doing more inspection in the field there. The other thing that I wanted to understand, as we move into the 2024 IECC is how approved third-party inspection agencies are going to be redefined in the 2024 IECC, which means that we can utilize this now in our code jurisdictions now. But what this new kind of definitions that have been created here in the 2024 ICC does is it talks about the third-party inspection agency relationship with the code official in a much different way. In essence, that this first section, the R107.4.1, really creates this idea of the authorization. How does a code jurisdiction authorize a individual to be an approved third-party inspection agency? Well, that agency needs to provide all the requested information and meet specific requirements to ultimately be authorized to work in the jurisdiction there, which ultimately means that jurisdictions need to think about what they're willing for a third-party inspection agency to do and what they're not willing for them to do. They need to think about creating a scope of work that says you can do this, this, and this, but you're not allowed to do X, Y, and Z. And in essence, we are going to authorize you to work in our jurisdiction, which means that they can also, this isn't a word, but they can also unauthorize somebody to work in that jurisdiction, which means that if they feel that the relationship between a builder and a third-party inspection agency is tainted, or they don't have reliance, or they don't have good faith that third-party inspection agency is working and doing their job properly, they can basically say you are no longer authorized to work in our jurisdiction there, meaning that they can't provide that inspection in lieu of the code inspector there. So that, I think, is really important and is going to help us move forward in potentially using approved third parties in a different way here. Now, the next part of this talks about the business identity, that they need to be an independent business identity, that they need to perform their duties in accordance with the scope of delegated responsibilities. So it gets into that responsibility of the code official actually creating a scope of work for the approved third party, and that the third party needs to disclose any conflicts of interest that they might have with that builder that they might be working with. There traditionally has been a reluctance to especially use approved third-party inspection agencies that might also be home energy raters, because home energy raters are paid by the builder. But that builder but I think we've overcome that in two ways here. One is that Energy Rater is an independent business identity. Two, the code jurisdiction is creating a scope of work and telling the third party agency what they're actually doing here. And three, you can basically take that business away from the third party agency by saying that you're not authorized to work in our jurisdiction, or you are. So there's a lot of control that the authority having jurisdiction has over that third party agency there to ensure that the integrity of the inspection is sound and solid there. The other thing that has never been really defined here before is that these agencies have the proper equipment, and that equipment is calibrated, because a lot of that requirement of these individuals and companies are to test the performance of these houses. And we need to make sure that the equipment that they're using is adequate to be able to do those tests there. And then that they are properly trained, and that they will be not only properly trained, but they have some level of authority. I can't tell you how often you'll go into a house as an approved third-party inspection agency and says, you don't have the authority to say if that insulation is installed properly or not. Only the code official does there. So if you're going to use an approved third-party inspection agency, you also need to give them the authority to actually pass or fail an inspection that you're asking them to do there. And so that this part of the 2024 IECC points that out there. And then lastly, we also need to report and ensure that communication between the authority having jurisdiction, the third party, and whoever is the builder in this case, everybody's being communicated with properly there. So it gets into how to report and communicate a little bit. So I'd urge everyone to take a look at this as soon as this gets printed and is distributed out there. But this is what we were able to get into the IECC and should be printed out there. So let's move on to other lessons learned here. One of the big lessons learned in IECC is that our HVAC systems won't work if our building thermal envelope isn't sound and working well there. And the IECC definitely is creating a sound building envelope, or has the potential to create a sound building envelope. And the IECC defines that building thermal envelope as an assembly of things that come together to create this boundary condition between exempt or unconditioned space and the conditioned space inside the house there. So it goes a little bit further and has us define that building thermal envelope on our construction documents there. Because it's an assembly of things, we can think of it as our air barrier control layer, our thermal control layer, coming together in alignment. And it also is defined as being continuous all the way around the building envelope there. So you might see it depicted on our construction documents in a variety of different ways, generally with a sectional drawing here. But the code is really looking at this kind of belts and suspenders approach, where we have a primary exterior air barrier, which might be the continuity of our exterior sheathing, and a primary interior air barrier, which would be the continuity of our interior drywall in our houses there. And then the code is telling us through requirements that we have to have supplemental air barriers where we don't have those those specific that specific continuity there. So we might have to add a supplemental air barrier behind a tub on an exterior wall, or on a knee wall on the exterior that's adjacent to our attic space there and whatnot. So again, the air barrier is looking at an assembly of things as well as the building thermal envelope. And its idea is that it's continuous all the way around the house. So our building thermal envelope, again, is looking for the continuity of our thermal control layer and our air control layer all the way around the house, and ensuring that we have that primary interior and exterior air barrier system and the continuity of both of these things all the way around the house, in order ultimately for our HVAC system to work and work well there. And then through requirements of the code, again, it's asking us to add that supplemental air barrier, and it's giving us a lot of examples of where that supplemental air barrier might need to be installed, like behind the tub on the exterior wall. But it says also where you come across it, maybe behind a fireplace or in a shaft, a wall assembly or a double wall assembly. You have to figure out where you're going to put that air barrier assembly. So we can leverage the power of the definition of the building thermal envelope to ask another kind of inspection question there. Do we want that specific component of the assembly to be inside our building thermal envelope or outside our building thermal envelope? And if we want it to be inside the building thermal envelope, then we need to ensure that the continuity of the belt and suspenders approach of our building thermal envelope is creating a complete and continuous barrier between conditioned space and unconditioned space that we're looking at here. So the code continues to think of this belts and suspenders control layers approach there. So we have air control layers, we have thermal control layers, we have vapor control layers, we have water control layers, but all those control layers are built into the building thermal envelope. So we might say that one of these planes are the primary air or water control layer, but we're building in belts and suspenders all the time from a code perspective there, because we know that water is going to bypass our exterior cladding. So we need a weather resistant barrier. They're both barriers to water, but they're working in conjunction together, for example, to work that. In the same way that the air barrier on the outside and the air barrier on the inside are helping our thermal control layer to work better, but again, in this belts and suspenders approach, making a more and more and better airtight assembly there. So, whoops, I went backwards. Lessons learned here. Again, we've got this table that's pretty much the exact same issues that the Energy Star thermal enclosure checklist is looking at here, where we're looking at the components as examples down the left-hand side, air barrier requirements and insulation installation requirements. But we need to understand that these requirements of installation need to be sequenced properly in order to get the air barrier to the bottom core of the truss, to the exterior wall. And now we can insulate over that whole thing, and that drop ceiling is brought into the conditioned space. And it's the responsibility of the framer to do these things rather than the insulator to make it happen there. So a lessons learned that we need these air barrier and air sealing details on our construction documents, that we need to know what compliance pathway that we're using there. And these documents, these details will help us execute the requirements that are actually in the code, but we know from the start point that the architect understands what needs to be implemented, and that the framer now can look at these and understand that I need to get these chutes installed, or I need to sequence this knee wall properly, because the details are actually on our construction documents, and it's going to make sure that we get the rim joist sealed to the subfloor, and the rim board sealed to the sill plate, and the sill plate sealed to the foundation, because it's actually explicitly called out on our construction documents to do that out there. So again, another lesson learned is that we understand the difference between construction documents and compliance documents. Construction documents have to be created by a registered design professional, but compliance documents don't. compliance documents are often created by approved third-party inspection agencies and or other trade partners. You'll see a res check, which is a compliance document created by an HVAC designer, or sometimes even insulators do res check documents for builders and whatnot. So we have all of these different compliance reports that we have to create there, and we have to understand who's creating them and also understand the information that's being required. Why is that information being required? And can we issue a building permit or a certificate of occupancy if we don't have all of these compliance documents there, and it's demonstrating that the house actually complies with the house. Moving on with regards to lessons learned is something that we've known for quite some time, but in essence, from an HVAC perspective, bigger isn't better there. We're trying to get right-sized equipment installed into these houses. So we need to do better heat load calculations. We need to understand the results. We need to understand the linkage between the building thermal envelope and our HVAC design, and ultimately select the equipment that's right for that particular house. HVAC contractors often don't understand the load calculations, and they historically, again, it's difficult to change our perceptions of what's happening in our houses. And potentially, I don't think so, but potentially in the past, it made sense to oversize a piece of equipment that's going in there. Let's say our air conditioning equipment that's going in the house, because it limited the warranty complaints that we might have had. But in today's modern day houses, it doesn't make sense at all. So what we learn is that if we fudge these details, we're going to get equipment that doesn't work in these modern day houses there. So from an HVAC design perspective, it's pretty simple. We need to calculate the heating and cooling loads. That's doing our manual J. We need to select the equipment that has the capacity to meet those loads, and then ultimately design the delivery system that's in those houses. And there have been some studies that have been done over time through the Department of Energy that shows that manipulation of that design process there can lead to tremendous oversizing. In this case, total cooling oversizing was oversized by 97%. So basically 100% oversized in a lot of cases, according to this study there. And that oversizing has severe consequences, especially now in today's world where we're trying to electrify our houses and install heat pumps in our houses there. So does the IRC and the IECC include the latest building science there? What's your thought there? Is that another yes, no question that you can throw into the chat real quick here? So we have some yes, we have some no. Again, it's a little bit all over the place here, but I would have to say that it does. It does incorporate building science and the latest building science there. And the basis of building science you can think of is being able to gain control and predictability in our houses. And the biggest way that we're going to gain control and predictability in our houses is by gaining control of airflow, moisture flow, and thermal flow. And that's the biggest reason why we're building our houses as tight as we possibly can, and then ventilating them correctly for the house so that we have better results and are better able to meet the expectations of our builders out there and our homeowners, more importantly, out there. So building science is completely wrapped into the code. And one way that you can see that is this basic move of insulation from the cavity to the exterior surface for greater condensation control there. And we don't have time to get into it in great depth, but we need to understand the building science there, especially again as we get into installing cold climate heat pumps into our houses there. We need to understand that we need to install cold climate heat pumps in our specific climates. And cold climate heat pumps are defined through the Energy Star program. And they have to have a certain amount of efficiency at cold temperatures, and basically 70% capacity at 5 degrees is one of the big things that we're looking for there, as well as their efficiency based off of a SEER and an EAR and HSPF rating system there. But what we saw in the Marshall Fire there is that some of the houses didn't get cold climate heat pumps. And at the beginning of our winter, we had a cold snap. And you can see the utility bill difference between houses that had cold climate heat pumps and houses that didn't have cold climate heat pumps. Now, luckily, these houses were also going for the Energy Star Next Gen rebate levels and the state of Colorado electrification rebate levels here. And therefore, those houses were able to leverage that and get the builders to replace the equipment and install the correct equipment in those houses there. But we don't always have that to lean on there. So we have to, from a code perspective, make sure that our systems are sized properly. And I guess we can only make recommendations that cold climate heat pumps get installed. But we need to understand the issue if cold climate heat pumps don't get installed, what kind of elevated electrical costs and other costs of ownership are going to be, as well as comfort. They pure and simply don't heat as well. And another reason I bring this up is I took the opportunity to look into the IRC and IECC a little bit more deeply and see if heat pumps are even addressed in any meaningful way in the codes. And I learned that they aren't really addressed in the code. HVAC in general isn't addressed except requiring a manual J, S, and D. They don't necessarily go into great detail, especially with regards to heat pumps, about other issues that are in there. So one of the things that I think we learned here as well is that code in itself is defined pretty differently depending on the audience that you're looking at. In this case, it's defined as rules and guidelines. And then we also have this strange relationship with this word minimum, minimum acceptable level of safety in our buildings there. And in a lot of cases, especially with regards to the energy code, we have a negative connotation with the word minimum. You'll hear a lot of people that say we're allowed to build the minimum worst house available from the energy codes. And the reality is that minimum isn't a word that should have a negative connotation. Minimum doesn't mean good or bad. It means a consensus-based body developed a code that says we need to reach this level of efficiency, this minimum level of efficiency that is good for the majority of people in our country. You're able to go beyond that, but the reality is that if you build to the minimum levels of the 2021 or 2018 IECC, even from the 2012 on, if you actually carried that out and enforced what was there, you're going to have a house that performs and performs quite well. Now, you have others that look at codes as laws. Again, minimum requirements, but these requirements are laws versus guidelines. And that's pretty different. And then we have, we talk about code and enforcement in the same way that we talk about kind of law enforcement there. So it's kind of no wonder that consumers have some pretty big expectations of codes. A builder says it passed the code inspection. The consumer is going to think that means something, that there's additional quality control, that these codes are set to create a certain level of efficiency and performance, and that the code, if it passes code, it means that it's met the letter of the law in essence there. And when you talk to code officials, you'll learn pretty quickly that code officials don't have the same understanding as consumers out there at all. Yet we are not really learning the lesson that we need to go out and educate the consumer about what codes are actually trying to do there. So that's my little soapbox on that. Lessons learned from the fire. Nobody really focused the rebuild on fire resiliency as well. There's some of the homeowners themselves that took it upon themselves to do that. Boulder County did extend its wild land urban interface kind of codes to the plains here. But what happened with that fire is it started as a grasslands fire. The embers of that fire, if it's an ember that's about a quarter of an inch or larger, it has sustained energy. And because of the housing stock and the ventilated attics and ventilated crawl space and the leakiness of those houses there, we learned pretty quickly that the embers got inside the house and started burning houses from the inside out. And then that started the house fire jumping from building to building in terms of proximity and density issues and whatnot. So engaging the homeowner becomes pretty important as we are developing codes and we're implementing codes and whatnot. It's the largest purchase that they're making with the least amount of knowledge about the product that they're actually buying or building in this case. They have serious expectations. They believe because it's new, it's going to perform, it's going to meet their expectation of comfort and all those things, and often it doesn't there. Now, is that the fault of codes? Not necessarily, but it might be the fault of not inspecting all the requirements of codes. Because again, if you follow the code and you built to all the requirements of the code, you're going to have a house that performs and performs well and meets our modern day expectations. These homeowners want to be educated. They're trying to do things either from environmental ethic or personal reasons there. And they're starting and have done a lot of research. So they're coming into it kind of educated, but they don't know what they don't know. So we shouldn't necessarily be afraid to talk to them about building science principles when we're trying to describe things in our houses. Talk to them about how heat pumps or electrification works in our houses there. You have to balance, getting into great detail about, I'm using heat pumps as an example here, compression, expansion cycles here. But again, regardless of what we're talking about, homeowners understand a lot more than we give them credit for. And I think it's going to help us understand that, because ultimately they're the ones that are living with this new technology, this new house, and they need to understand how to operate these systems, and they need to understand how these systems work. And going back to from the code perspective, they need to understand what code does and what code doesn't do in our houses there. Why we're moving from the old HVAC system that works fast and furious to these modern day heat pumps that we really need them to run long and slow cycles there. So to conclude here, we've had some bad experiences in the Marshall Fire, and often those bad experiences are amplified to such an extent that we don't hear about the good things that have happened as well. We need to think about adoption, enforcement, and education from the perspective of codes and programs and how we're actually implementing all these things. I believe that we need to engage the homeowners and help them understand codes and programs and how they're being utilized to achieve their modern day expectations of comfort, efficiency, resiliency, all these things that they expect of their homes. We need to understand the building science, and then we need to look for it in our codes because it is embedded in our codes there. The building science is all about building tight, ventilating right, gaining control and predictability, and utilizing the science to be able to do that. And it is wrapped into the codes there. And then we need to think about and be prepared for what's coming. Because I used electrification as an example often here because electrification is coming, and we're going to be needing to address these details and these conversations even more as we move forward, because I don't think we're going to be going backwards here at all. So thanks again for your time. I appreciate all of you for listening and commenting as you go through here. If anybody has any comments or questions, we're happy to stay on and talk a bit more.
Thanks so much, Robbie. It looks like we've got a couple of raised hands. I know, Brad, you had your hand up a little bit into the session, so I'm going to go ahead and ask you to unmute yourself and you can ask your question directly. And you are still muted.
That's Brad Dassler, in case there are more than one Brad out there.
Okay, we're going to move to Derek. I'm going to go ahead and allow you to talk. Do you want to ask a question?
Can you hear me?
Yep.
Okay. So one thing I would say with third party, in terms of relying on them completely for house raiders or and Robbie, what I'm talking about in terms of quality. Some of them aren't that great. I've actually gone in and found areas like underneath stairway landings on an outside wall where they totally missed it because they didn't want to bend down and crawl underneath that tight little triangle to find that area where it's missing. I have roofs, sometimes attics that are attached to a wall, and it's basically from the outside, it's just a little shed roof where they bumped out a room below, and you look up in and you see where the wall insulation ends, and then you're looking at rafters. And again, there's no insulation in some of these really tight areas, these less obvious situations. So even though we may rely on these contractors, I still would say be able to follow up on them and look for those difficult spots where it's tough to get to, hard to reach, and not a normal situation.
Yeah.
Behind the tubs, behind the bay windows, the difference in ceiling heights and vaulted ceilings, tray, coffer ceilings, those are the obvious ones, but just to keep your eyes open.
Yeah, and I don't disagree with that at all, but I do think what's coming in the 2024 can help us help everybody do better, because you can clearly say, if I no longer have confidence in you, you're no longer authorized to work in my jurisdiction, and or you can have a scope of work that says you need to look at these specific areas, or these specific installations. We can leverage these things to help everybody do better, and begin to, I think, especially with the energy code, we might want to have specialists that are inspecting that's part of it. But again, that's my opinion, and I hope that we've put in some tools to make it better as we move into the future here.
Yeah, thank you. I appreciate the changes.
Thanks, Derek. All right. I believe, Bevan, you've also got your hand raised, and I know you put a couple questions in the chat, but if you want to go ahead and unmute yourself.
I was just curious when 2024 IRC will be available. I know you and I had talked about it on the email, and just want to know when that's going to come, when we'd be able to move to that.
That's the $1 million question right now. Right
Okay.
now, it was supposed to be out the end of May,
Got it.
and we just don't know. I mean,
Okay.
Yeah, we keep hearing soon.
Soon. Okay. And then the other was, do you see, like, I'm in Silverton, so it's pretty isolated community, the benefits of managing the performance ratings as well as inspecting versus relying
Yeah.
upon third party.
So the performance compliance options aren't necessarily ratings on a house.
Right.
It's a more sophisticated modeling approach to propose what somebody wants to do on the house. And I don't think it really requires much management per se from the code jurisdiction. What it requires is actually collecting and understanding the reporting that's coming from that. Now, what I was saying with regards to the inspection side is that because you're required to submit a compliance report proposing what you're going to do in that house to get your building permit, but also requiring a compliance report that's confirmed at the end of the process before you get your certificate of occupancy. That means that the whoever's doing that software analysis has to do some level of inspection to know if what they proposed was actually carried out. And because of that, you might be able to leverage that individual as a third-party inspector to do that level of inspection. And that's the part that you might have to manage.
Okay. Yeah, I'm saying, do you see a benefit in me as an inspector taking over that role to ensure that homes are being built to the, IECC, or
Yeah.
in this case, doing a blower door test to achieve the proper tightness?
In your jurisdiction, it could make sense to do that because you have limited individuals who are specializing in that. And there's nothing in the code that says that jurisdictions and code officials can't do the energy modeling or can't do the blower door testing and those types of things. But as long as you feel as educated about doing all that work as you would require anybody else to be, in some jurisdictions, I could see where it could make sense.
Sure. I mean, in some ways, I look at it as a way to offset. If we didn't charge for it, it would be a way to incentivize builders or homeowners to go in the direction of higher efficiency and meet those requirements.
I'm not sure I said it very well, but the idea of doing our builders a disservice when they say, just tell me what to do, and we point them to the R value table, they're not getting educated in how to actually install these things or think about insulation, not just from an R value perspective, but from a condensation perspective or these other things. I think we're doing them a disservice because they're not really growing as professionals in the industry that they've chosen to be in.
Right. And when you build a home that's that efficient or that comfortable, that the homeowners never forget that, and they can remind the builder of that, or they at least have that as a resource in the future.
For sure.
Well, thank you.
Thanks, Bevan. All right. I think those are all of the questions that I see. So I'm going to go ahead and stop the recording. And thank you so much for everyone for attending. We hope to see you in a couple of weeks at the next session. And thank you, Robbie.